I'm Alex Tisse.
My name is Luke.
We're both cloud architects from Xpirit in the Netherlands. And this afternoon we're going to talk about how we run a DevOps-style production cluster on Kubernetes in the Microsoft ecosystem. So we're Microsoft guys.
Pretty much.
Who of you is also using Microsoft Azure Visual Studio? Be proud, come on. Okay, good. The other ones, AWS, GCP, or Google Cloud. All right.
Mostly Azure. Good.
So, mostly Azure, yes. That's good. So we'll have a few slides to get you through a couple of things, but a lot of demos as well. We're using a use case that we have for a customer as a basis of how we think you should run a container cluster in a DevOps team. It will be a bit biased, as we said, Microsoft, but we will be using and talking about Docker, Kubernetes, and Visual Studio 2017, and Visual Studio Team Services.
All right. So whenever you're doing such a project, it's always important to start with the end in mind. And that means that you take it all the way to the professional level from the day you start. So what happens, you automate everything, for instance, and that means that you don't just write your code, but you also make sure that whenever you do stuff, maybe create an environment, you make sure that it's ready for production.
Yes, so it's about the vision that you have in the end, getting there and not taking any shortcuts. We took this picture, Elon Musk wants to go to Mars, but he's already doing the booster rockets to land. So take that with you, and from the very start, make the effort to do everything like you would be doing it in the end, and not skipping parts and saying, we'll do that later. That's helped us to do it straight from the start. And it does hurt a bit, because you need to take care of a lot of things that you feel like, do we need to spend time here? But be pragmatic, do a minimal viable thing, and then move on. But always towards your goal and your vision. And that brings us to what we think, how you can have your cluster with containers and do all the DevOps stuff. Now, we're not going to talk about DevOps practices, but we have a lot of things that we feel are important if you want to run DevOps and you do have to take care of your cluster. And all these things we are going to talk about. Luke already mentioned the automate everything, but there's more. It's about monitoring. It's about being able to react fast. You see in the background, there's all these people working on the vision, going to Mars, working on a satellite, multidisciplinary team. Each has their own task, but the shared goal is getting all these things done as a team. So that's the DevOps part. And then there's the customer that wants to be faster, better, and cheaper. And the rest of the talk will be about all of these items and how you do that with your cluster.
Well, to demo all this, we've created a small application. It's about tracking high scores for games. And it's a really simple application, so you can all get on board quickly. So the application consists of a ASP.NET Web app, and the ASP.NET Web app calls a web API, and the API uses a database to store some data. It's really simple, and this is the main focus.
Yeah, and we've simplified a little bit. So besides a web API where games can shoot the new high scores, we've taken most of it out. And what remains is this front end with a web API with a database server. So to remember those three things. It's a gaming web app, a leaderboard web API, and your SQL Server database underneath. So you'll be seeing much of this as we move along. Shall we show the? Yeah, we'll show you.
Quick demo.
This is that page. It's a simple page. It shows the high scores. It gets the high scores from the leaderboard web API. There's a lot of scores there. Let's see if there's any new scores. So we'll refresh the page. And we'll refresh the page.
Try again. Yeah.
No. Oh, do you recognize this? Maybe you do some demos. Maybe your customer is looking at your application. And the moment you do something, it breaks. Or maybe it broke before. This is actually the first part of our story, because, you know, when the brown stuff hits the fan, you want to be informed. You don't want to find out at this particular moment that, oops, things are not doing that well. So let's see, we've got the application running in a Kubernetes cluster. So let's see what we can find out what's wrong with our cluster and with our application. So we'll go to, we'll set up a tunnel. So we'll do the Azure CLI tooling. AKS is the Azure Kubernetes Service, which is a hosted version of Kubernetes. We'll put up a tunnel to our resource group where our cluster is deployed, and it will just get all the data, spin up the Kubernetes dashboard, and let's see what it's doing.
Yeah, so what you see here is the Kubernetes dashboard. Maybe new for you, but maybe not. We'll spend a little bit of time here, and let's have a look at some of the gauges that you see. So you see that everything, well, it's green, so that's usually a sign of health. What you also see is that we have a couple of deployments and a couple of pods. And the pods are the things that run your containers. But what we notice here is that two things. One is that the amount of restarts, well, it should be 0, because a restart usually means that something is wrong. And you also see that it's using 0.25 of the CPUs available. And this may be an arbitrary number to you, but as we are the developers of this application, we happen to know that this resource was limited to 0.25 of a CPU. He's just looking it up. Yeah, there you go. So this means that apparently we have a CPU burner, and we have a process that uses every shred of CPU that's available to it. So even though the Kubernetes dashboard didn't report any errors, well, something is wrong.
And our Visual Studio is wrong too, but we'll fix that later.
It's part of the demo.
Okay, so we're hitting a hard limit here.
Yeah.
So it restarts, just like a container service. So we're hitting that limit. Actually, we're running, let me switch back to that. We're running a particular container here. If we make it a bit smaller, and then look here and make it a bit bigger with zooming, we see that we have the gaming web app version 99 deployed, which is actually a build number that we tag the container image. That's what has been done here. This is currently running. So what should we do next?
Well, wasn't there a release this morning? So let's have a look at our release pipeline.
Yeah, but is there more that we can see? Maybe we should have a look like. So we actually have more, because since we're running in Azure, Azure has all this built-in telemetry as well from all the Azure resources. You can use, for example, container monitoring solutions from Operations Management Suite, OMS. It has a rich telemetry where an agent runs in your cluster, and it extracts all the operational information, CPU usage, memory usage, and you have all this dashboarding here where you can actually see what is happening in your cluster. So that's an additional point of information. We still don't know that much, but if we go to Application Insights, which is Microsoft's monitoring tool for applications, we can go to, oh, that's the wrong one, this one, Application Insights, which also extracts data from your Azure resources, and you can build in the telemetry in your application code. So it sends out more information. Usually there's just a bit of bootstrapping involved, and once you have it, it will do all the correlation across calls from your web app to your web APIs, to your databases, from front ends to storage in your cloud provider. This is Microsoft specific, so this works particularly well with all Azure resources. And then you'll get these application maps. Our application is fairly simple, but here we can see the first indications that if we look here, the calls from our application to the service of the leaderboard web API is actually failing. So there's 2,300 canceled and faulted calls. And if we investigate those failures, we will be able to drill down. So here you see that in this time period, there were a lot of failures. Going even further, it's failures of calling the leaderboard web API. So we can even drill down a bit more. Look into the leaderboard web API, And then you'll see in a bit that there's calls coming from the front end to the service, and there's exceptions. Things are being canceled because the cluster is struggling. The web API is not doing a particularly good job. It takes too long for it to complete its action, which is not too bad for the front end, because the front end takes care of it. We have resiliency built into the front end. That's why I did show the page without the high scores. We want to make sure that if we have any dependencies, that we don't crash if the dependencies crash. So that's another thing. Make your application robust, design for failure, because it will happen, and you need to be able to take care of it. So if it takes longer than 1.5 seconds, the front end kills everything, and that's what you see happening here. So at this point, with these traces and additional information, we know that something is wrong inside of our web API, not the front end, even though that's manifesting the actual mistakes.
So you get a degraded performance. So the front end still functions, but the API is broken. It doesn't mean that the front end needs to crash.
Okay. So what we do is we'll have a look. This is Visual Studio Team Services. This is the integrated application lifecycle management, taking care of all your code in a repository, the building of your code, releasing of your code, and all the work item tracking, because you want to track your work. So this is Jira, Jenkins, and some other tools combined into one SaaS offering from Microsoft. So we see that this is an hour ago this morning, but we did a release. We could have a look at the release, what happened there, and it will show us that we had a successful production release, and we want to find out what was actually deployed. We know that it's image 99. Would this be the build that took care of it? And if we take a look here, it's a bit smallish, but I'll zoom in. You see that it's build ID 99. So this is actually the build that caused the things to change. Then we want to trace to that. Well, what do we do for this release? We actually did this build. This was the build that led to this release. It's an automated release, so whenever a successful build is completed, it will automatically start the release.
So what was done to create that build? What code changes were made to create this build at all? Well, we can see that by investigating this list, and you can see that there are a bunch of commits that were part of this build. And, well, usually, because the failure didn't happen before that build, you can safely assume that one of these commits here was the cause of the failure.
Yes. So I actually did a bit of an improvement this morning, for the sake of the demo, of course, but we just pretend that this is real. So I made some changes, awesome improvements. And as you can see, these are some of the code changes. And by the looks of it, this is what I did inside of the leaderboard controller, an MVC pattern where I introduced some new functionality. That wasn't such a good idea, maybe. So let's see if we can fix this.
Can you show the default value?
Oh, yeah. So we have this, I'll zoom in a little bit. We have this paging functionality with a default value of 0 and a pretty naive implementation that shows it does something. But in this case, it's just eating up CPU cycles. For the sake of the demo, pretty stupid mistake as a demo bug. Yeah, we want to get rid of that.
Yep.
So we'll go back here. We'll quickly show you the outline of the solution. This is a Visual Studio solution. It's 2017. It has a .NET Core application for the front end with the usual .NET Core stuff. If you're not into it, it's just the implementation. Then we have the web API. It also has a .NET Core implementation. It has Docker files that do a multi-stage build inside of an SDK image that was able to compile everything, multi-stage, so you get the really optimized images as an end result. This is what's being prepared as a result. And the Docker Compose tooling, we have a special Docker Compose project, lists out all of the images and services that are being used and built. So in this case, we have the gaming web app.
It has an image name, gaming web app, and the leaderboard web API over here, referring to the particular Docker files for each of those solutions. And we have an image here for the SQL database. And we'll get back to that later. Why are we using this SQL database inside of our container cluster?
From the error messages in the monitoring tools, I remember that it was the leaderboard controller in the web API project that had the issue.
And when it calls it, it actually calls this method. So it's a get method. It's also the thing that changed with the value and the demo bug. So in this case, we should be able to
get rid of
revert what we've done,
yeah.
And have the original thing here.
Maybe even delete the argument.
We can even delete the argument, like so. Now you might have answered my question, why do we fix the code instead of reverting to the previous version? That's one of the things we believe, that if you are able to really quickly build and fix your solution and deploy it to production, you don't ever have to roll back to a previous version. You only move forward and you roll forward with new fixes.
Yeah, what if there were a couple of database changes that were part of your upgrade? It would be, well, it could be really hard to undo those database upgrades. So this is why we say roll forward.
Yeah, we'll go back to a few slides because we want to highlight a thing. So we did talk about the monitoring and the traceability. That's how we actually drill down to the bug. Locally, we would want to debug, find the bug, write a unit test, and do this small inner loop cycle that allows us to quickly iterate on our own development machine, not dependent on anything else. And that's important because then you can do everything without your cloud resources in full isolation. You could even do it on a plane, flying in and having no internet connectivity.
Yeah, let's run the project and see what happens.
Yes. We'll run the project. There we go. So what Visual Studio now does is it will use the Docker Compose files, the Docker Compose YAML, the Docker Compose override. The override has all these environment variables for the listening ports of the application, and Visual Studio also generates some additional override files to do volume mapping into our source code, so we can actually link up what is inside the image back to the source code on our file system. If we run this, there's a bit of a race condition locally, but you can see that it actually is working again now. This would manifest the same mistakes, and we didn't show you how it was malfunctioning even locally, but this is just to show you it is working. We have some dummy data, and the dummy data is not the live data, the bigger list that you saw when we got started. This is some seeded test data inside of our SQL Server database. The reason that we can do this is because of this.
Well, containerize everything. That means that, well, we have a container cluster, and obviously it's running our application. But we also have a couple of dependencies from within our application. So maybe we are using a SQL database. We may be using a service bus of some sort. We could have a dependency on a webhook somehow. So wouldn't it be nice if we could just take those dependencies and also run them inside the cluster? And by having that, we get the capability of running a standalone version. We get the capability of running a dev test environment, integration test environment. So it would be very simple to just roll out new environments. And since we automated everything from day one, it's just a matter of supplying different parameters.
Yes. And so do realize the problem, if you want to run isolated, is in the blue part, your external resources. So if we containerize everything, why not take stun doubles for each of those and put everything inside of a container? So here you see the replacements. Instead of the full Azure SQL, we'll use SQL Server on Linux from a container. RabbitMQ, just like Luke said, but some of them might not be under your control. If you have a webhook to, for example, GitHub, you can't containerize GitHub, right? Even though it's owned by Microsoft now. Maybe we will in a while. But so we need to take some special measures. If you want to swap things out from your code, you would need some provider patterns, some design patterns in your implementation, dependency injection, inversion of control, those kind of things, to swap out your implementation for Service Bus with RabbitMQ, as an example.
Well, there is this thing about running a database inside a container. So SQL Azure offers you geo-redundancy, automated backups and restores, automatic failover, all sorts of goodness. And running a database, a single database inside a container, well, even though it's on a cluster, you don't get all that stuff. So for dev and test, this is an excellent solution for running locally as well. But for production, well, you may want to reconsider that.
Yes. And to deal with the external resources not under your control, you would create some stubs, just like you would for unit testing, and have some similar behavior and cutting out that dependency at wherever you consume it. So with that, we are able to fix it. We just did. We've asserted that it actually works. So our inner loop is complete, and then we want to go to the outer loop, which is going to our cluster. We want to push the code that we have as an image into the cluster, and we need something completely automated for it. Well, that's where the tooling comes in again, tooling of your choice, but we've picked source control for Git. So whenever we do a commit, you can actually kick off an immediate build, like continuous integration. And the continuous integration pipeline will build your binaries, create the images from the Docker files, and push the images into the registry. And from the registry, it will, a second pipeline, the release pipeline, will instruct the cluster to pull the new images and thereby going to the new version. So this should all be very smooth. Then it's running. We showed you all the monitoring telemetry, but to help out with investigating and communicating with your cluster, you can actually have additional agents and bots, and we'll get back to that in a bit. With that, everything is running there, and then we have the continuous monitoring and the feedback, maybe from usage, from a functionality perspective, which features are being used by customers, and you get back to your inner loop, you create work items, and you pick up the work, do new implementation, and go through the outer loop again.
So it was the monitoring that brought us to this exception, how to fix it, and it will be the monitoring that tells us it's okay afterwards.
Yes. So let's quickly get this code into production. Let's see if we actually automated this correctly. So what we'll do is we'll go to branches. We'll create a new branch. Do you see? Actually, I did use a feature branch for what I just created, but we'll create a new one. We'll call it hotfix, and we'll check it out. So now onto the hotfix branch. This is our code change. It compiled, and it was actually good. So when we go back, we see our changes. We'll cherry pick the things that were changed. This one, we'll stage it, and then we'll say hotfix paging. There we go. We commit it. And do we need to, well, we'll just do this. Do we sync it?
Push it.
We'll push it. So we'll go back.
Sync tab.
Sorry. Oh, now we're messing it up. We'll go here, we'll push it.
If we had a continuous integration pipeline, a build would be scheduled automatically for this branch right now, but we chose not to have that because we have limited build minutes available. So what we'll do now is we will take this pull request and merge it directly to master, create a build, and then while that's running, we'll zoom in how this process works.
Yes, so we will include the nodes if there were any. So this is the hotfix for the paging. This is a pull request. Looks good. We have some reviewers. We'll create a pull request. And when it's there, somebody needs to approve it. I don't believe you will want your name on this, this request, so I'll approve it. But you can set the policy so somebody else needs to approve it, or maybe multiple persons need to approve it. There is a story on compliancy that you can maybe tell.
Yeah, well, you can configure it in such a way that a different person needs to apply this change. And the cool thing is, well, not only our source code is code in the repository, but also our infrastructure is. So if you make infrastructural changes, they end up here as well. So we can assign maybe a security officer to review the code changes we have.
Yes, and it's also the compliancy thing, whereas multiple eyes, 4 eyes principles will be covered. So we did all that. So it's now inside of our repo, inside of the master branch. We can go to the build pipeline and actually kick off a new build. So that is as easy as this. So we'll get that started. We'll queue a new build. It's using a hosted Linux agent because we're building Linux images. And it has been queued. But that will take a while. So there's this, this user interface that will take us through all of the steps of the build. And it will show us if that's, how that's progressing. But while that is going on, we'll quickly look at all of the pipelines that we created to do this full automation, fast rev into production. In this case, the build pipeline has a couple of steps. Docker Compose tasks, which are the building blocks for a pipeline inside of Visual Studio Team Services. The binaries are being built by the Docker Compose. So the same tooling that is used inside of Visual Studio is also used in VSTS in the cloud. After that, we'll build the images and we'll push the images to the registry and do some administrative stuff to get things completed. So that's what's happening here. We build the images and push them into the registry. After that, we have the release pipeline.
Yeah. Well, the release pipeline definition is actually quite simple. So maybe you know, maybe you don't, but you just saw the YAML file from Kubernetes, and the YAML file describes our desired deployment state. So what it has, it says run these and these container images in such amounts. And the only thing that we need to do is to say to Kubernetes, apply this YAML file, which is the same file as the previous release, but only specify a new version number. And the way we do that is by having a replace tokens task. And we have provided a Kubernetes YAML file that has a placeholder. And this release replaces that placeholder with the build ID, which is pretty much a version number in our situation, and then calls Kubernetes and applies that file.
Yes.
So it's very, very simple.
And the other thing that we did is the infrastructure provisioning pipeline. So we did the same thing for an automated release through a pipeline into production. So this is actually also a 3-phase step. You can combine all of these steps into a descriptive way of doing provisioning using a declarative form. Desired state configuration is another term for it. This is how you can actually spin up all the resources and destroy your resources as well if you want to re-provision everything from scratch.
So if you want to add a new environment, let's say a test environment, it's just a matter of adding an environment here and specify different configuration variables.
Yeah, and now for the exciting part, because we kicked off a build, it's still in progress. Let's see how it is progressing, because it would be cool if we could finish this within the session. So we're waiting for some output from the console. Some steps have succeeded. You see it's actually playing the Docker file. So it's speeding up now. It has to initially download all the base images from the build agent. If you have your own build agent on premises or on your laptop, this will be much faster. But this is the installation of all NuGet packages.
Maybe go back to the slides and revisit this later.
So that we'll let this run, and we'll go back to the slides. Yes.
All right. Well, we've pretty much covered automate everything and treat infrastructure as code. So what we do is we treat source code and infrastructure definition exactly the same, and we can have auditability on both.
Yes. So where sometimes you have a description in a Visio document or a Word document describing your infrastructure, and that's what you hand over to the compliance and security office. This is what it should be. Doing it in the other way, a descriptive, declarative way, you can actually see this is the technical artifact, and what's here is also in production, and there's no mismatch.
No. All right, well, suppose that you have an R2D2 running inside your cluster as well, and not the actual guy, but some bot that you can chat to in a chat window, maybe using Slack or something, and then ask that bot, oh, is the database still alive? And maybe you forgot to do a database migration with the previous release, and wouldn't it be cool to have that bot be able to do that database migration for you? And for every minor issue that you encounter in your product, well, just create a bot command that can fix that. So what you get is a chat window with the bot and you and your colleagues. And they can all read what you already tried to do to fix this error and what I did, and well, maybe learn something great, and have that bot be able to do second and first line support for you.
Yeah.
We're not going to demo this, but well, think about it.
It's actually what we build in the project. We build a Slack channel, and the Slack channel has this bot that you can communicate with. Yeah, so we're almost there. Let's see how this is going. So it has been pushing the images, it's getting the images, pooling them again, including the checksum. So that's something that you could use when you are wanting to make sure that you actually get the exact right version of your image file. So this is all completed now. And we immediately kick off a release build. So as you can see, the release 10, it's blue in progress, which should be fairly, this is a bug in the UI or in Edge, I don't know, but we need to run that again, like so. Yeah, since shortly. So we are in progress. The agent is ready, so we're connecting now. So what it will do is it will get the YAML file that we need to deploy it. It has the tokenized placeholders for the version, so we'll insert version 100. That's probably the next ID. And if this is running correctly, sometimes you need to refresh it a bit.
Reconnect the tunnel.
We also need to reconnect this one. That we'll do in the meantime. This will sometimes quit. So we'll do a new tunnel. And we have that ready. And here we go to the release. So it's initializing. We have 2 more minutes, so I hope we're good.
It'll work.
So shall we do the finishing of it?
Just refresh once.
Yeah. So we'll do it here. That's the better refresh. Yes, so it's doing a cube control apply. Let's try that again. We're going to really want to make sure that it's completed. It's still a bit in progress. So the apply is actually telling, oh, so it succeeded. We can go back to our home page. That's the wrong one. We'll take this one, the one that broke. Let's see if it's actually working now. And this is where you keep your fingers crossed, right? So gateway timeout, it's spinning up. Well, we could actually look at the overview again. So we're still green. This is the newly spun up thing. And it should be, if we refresh this, it should be using the new version. And you see it's actually going down in memory. It's 30 seconds up. And if we go here and refresh this, we're back to being good. So with that, what we hope we showed you is that if you do DevOps and you automate everything, you're able to monitor and find out before others do what is happening in your cluster and in your application code. You have a full traceability in place to find out where it actually is, and you're able to release it very fast back into your test environment, then into acceptance production, or maybe even straight into production. Containerize everything so you can have the inner loop to speed up fixing things and building new functionality. Then we think that you are in a good shape for doing DevOps with your cluster. We showed you in 30 minutes how we go from a broken release to tracing it, fixing it, and releasing it again. And that's it. Thank you very much.
Thank you.